Right, I'm going to desolder the POL on this Cobra 25. I have to take the POL out in order to do the frequency conversion to replace it with my own modification board. So I'm just going to desolder that now. One day I'll get myself a decent desoldering station, but for now I'll have to do the old solder sucker weight, which has always worked fine for me in the past, but it's not ideal, you know. I'd love to actually get a proper soldering station. I might have to put some solder on these actually, freshen them up. Sometimes it helps get them desoldered. Yeah, it's not desoldering very well. I'll have to do that. Put some fresh solder on. I don't have my air filter currently running because the noise would drown out the audio. So I'm trying to not breathe this rubbish in. So yeah, let's put a little bit of fresh solder on there. It just helps to help it to desolder. A bit of fresh stuff. It's a bit mucky looking and stuff like that, but it's fine. It's just for this. And this capacitor's in the way a little bit. Right. Let's try it again. Yeah, that's better. Come on. So getting a proper desoldering station would definitely be nice. So my list of things to get. I was actually looking at one earlier today, but there's a few options out there from China, like AliExpress and places like that. And you never quite know what you're getting. That's the problem, you know. Some don't come with extra nozzles and things like that, which is the thing you need. You have to get the right size nozzle for the thing you're desoldering, so it works more efficiently. Although that said, this has got one size and this works fine, so you know, who knows. Yeah, certainly worth investing in, I think, but it's going to be a few $100 with the looks of it. So as you can see, this handheld solder sucker works just fine when you've got decent solder on there. So yeah, now it's just see if these are all free. It's moving, 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 moving. It's all good. That one's bent over. Let's straighten it back up. I think I might just toss in a little bit stiff around here somewhere. It might not be completely free, but it's just let's see if we can pull it out. Let's give it a go. Let's just lift this up a bit so you can see. So let's get in there with this. Yep, I can't get on the other end, unfortunately there's a capacitor in the way. Don't think I can quite get in there. Oh, here we go. Right, it's just about there. There's a couple of pins a little bit flared, I think. It's almost there. Yeah, right. There's a pin here somewhere, it's a bit stuck down there. I'll get it out in a second. Right, here we go. Just use tweezers on it. There we go, done. So, POL out, as you can see, if it will focus on it. Yes, so that's that part done. Alright, this is my modification board. I've just got to strip out the wiring and stuff, so there's a little ribbon cable, little IDC plug I use on here, just to simplify installation, just plugs onto there. What I've got to do is strip all these wires off and get it all good to go. So I've actually got a rather convenient stripper here for ribbon cables. So let's just give that a strip. Okay, done. It's certainly easier than doing them one at a time, which is how I used to do it. And two things with it as well. I've actually got these two wires here. One of those is for a switch, and the other is for the TX input to the board. This one here, which is by itself, isn't actually used in this situation, so I'll just leave the wire there like that. It could possibly be used at another time, so I don't remove it completely, I just don't connect it to anything. So now I'm just going to tidy these up and solder them all up, getting ready to go. Right, I've done the wires, soldered up. Now I just need to try and get them into the PCB. Problem is the spacings of these ribbon cables are very different to the actual board, actually half the distance. So the board pins are obviously for the POL is 2.54mm, and these are half that. So what I need to do now is insert this into the PCB, which can be a little bit tricky, but that's why I spread them out like that. It just helps get them in, and I can usually, if I get it right, get them all in just all nicely one after the other. Usually I'd actually like to find some ribbon cable with the correct spacing on it, and maybe change my modification board to handle that, but yeah, we haven't got there yet. So yeah, that's not quite going in there. We'll get there. So I'll get this in, then I'll come back. Okay, I've got the ribbon cable in there. You have to excuse the ugliness of the way I'm just going to solder this. It's not great, but I just need to get it secure, then I'll come through later on and do it properly. Right now I just need to get the things in so the cable doesn't fall back out, then I'll resolder it all properly after that. But just have to do what I can right now so it doesn't fall out. Once I'm happy with that, then I'll just come and I can let go of it and do it properly. This is quite ugly solder, lots of flux in it, but the flux is really good sometimes when you need it to clean up the board and stuff like that. Okay, I think that's okay. Let's do this properly. Again, I haven't got my filter on. If you do a lot of soldering, get a filter and use it. I currently don't have it on purely for the video, otherwise you won't be hear a thing I'm saying, because the filter is actually going to be right above the camera, or the phone, because I use my phone to record. And just tidy these up, it's almost right. And this one here. Okay, those are all good. So obviously I'm going to solder it all on and get it all nice afterwards, so there we go. I've got some more to do yet. Right, I'm just ready to put these other two wires into the board here. So I had the first set of ribbon cable which I put in, which goes to all the POL input pins and the ground. Although the ground isn't strictly necessary because I do ground it in other ways anyway, so it's actually got multiple grounds. Connections to the 0 volt side. The ones I'm putting in now are the POL supply and the phase detector output. So those are connected. Now it's got to solder those in. Again, I'm going to have to do this in a slightly ugly way, but this is what's necessary to get the job done. If the wires haven't fallen out, I think one's still there. One might have just come out a little bit. Like I said, normally I use a filter because really this stuff is not good for you. You should avoid breathing it in. So that's in there good enough. Okay, that's that part done. Keep going. So something I actually do is I actually install dual bands on these things. So what I'm going to do is I use the channel 9 switch. So I'm going to disconnect the wiring on here, disable that, and just make sure it's linked across so it's always on normal channels. And then I'm going to wire up, or start wiring up, this ribbon system to that switch in order to allow me to switch between New Zealand and FCC band, and that will just allow that switching. Then I'll carry on. I've got to do more wiring around the POL yet, or POL location, so we'll get to that soon. Right, I'm going to start soldering these wires in. I've already prepared the switch. I had to scrape the terminals off a little bit just to get a nice coating on there so they're soldered here properly. And this wire here is a transmit wire. Well, will be the transmit wire to the modification board. I've just got to solder that in there. Get it there. Okay. I was doing all the other soldering with the camera not recording, so I could have the fume extractor going in to make sure that's all good. Now this one here is the control wire for the band. So I've got to stick this on here. I thought I wanted to show you this part of it. Come on. If I stop moving it probably helps a little bit. Okay, that's that one there. So that's those on. Now it's got to do the link up to the microphone input. Well, the TX input should I say, which has got to go onto the bottom of that switch on that bottom pin down there. And then on the top pin I've got to link over to the POL location pin number 8, which is that one there. And that will then allow me to control the transmit TX input to the control board, which has got to shift by 5 kHz, stuff like that between bands, so it's got to do all that weirdness. So it's required for that. I've also got to come over here and around here somewhere. I think it's that one there. I'll have to double check. I'm pretty sure it's those two pads there. There's a capacitor which I have to bridge across with a resistor in order to lower the voltage going to the channel selector system, and that's to prevent any damage occurring to the modification board from the voltage being too high. And I also have to pick up the mic TX input from over here as well. See, to pick up here than it is from on the side. It just taps straight onto that board, wire straight across. So I believe it was, from memory, I think it's that one there, but I'll have to check it on the other side of the board. Right, so before I do the voltage change, I'm just going to show you this. So at that point, just this little track runs along here. There's variations of this chassis. The 25 Limited is lots of different versions. It's actually surprising. They've all got the same name. They all look very much the same. This one's got the side mic socket, so it's a bit of a different version. But there's several different PCBs versions, and they actually have slightly different configurations. So there are variations. Got some like with the board part on the front, which isn't populated, or maybe populated with the board if there's the weather station one. So in this case, this is a bit different. Normally that black wire there is normally at that point there. Because I've disabled the channel 9 switch already and unwired that, I've moved it to the ground point ready for, because I'm just reusing that wire. That green wire there is normally going to the switch, but I've attached it to here. Okay, so normally there's a black wire there. That black wire is here normally, but I've swapped it around for the channel, disabling channel 9. So that is there, and the voltage you're getting is 7.2 volts. Okay, so with that, now I'm going to modify it, and I'll show you the voltage after that. Okay, so I was going to solder this up and get this ready to go. I've got a resistor half cut. See, I need a ground pin, so there you go, there's an earth right there. So I'm not worried about all the flux and mess at the moment. I'll clean all that up afterwards when I'm finished. Let's get that in there. Okay, that's that side. Now let's go over here. It's going to go to these pins here because they're just convenient to go to. It's actually, well, maybe there. We'll see. Might be a bit long actually. No, I'll go to that one. That's right. We'll go to there. So I'll cut that off there, the right length. So that's done. Put a bit of fresh solder on that end. Then I shall use my tweezers to get that on there. The radio's still got power on it, but it's actually turned off. I'm not actually touching anything which has got 12 volts on it, so I tend to be a bit lazy about turning radios off like that, but as long as you're not working on a bit which is potentially live, it's okay. Right, so that's the resistor on. So now I should be able to turn it on and see a different voltage here. Okay, so I'll come over here now. 4.7 volts. Okay, 4.8 nearly, which is just about perfect. So I can't exceed 5 volts going onto the board, otherwise it could potentially cause damage to the EEPROM. One day I'll actually look at updating the technology I use. EEPROMs have worked fine. I've got stacks of them. I've got heaps of these board parts. I mean, I've just had these boards made. I did used to hand make them, and I've just actually had a whole bunch done properly. So I was kind of tired of drilling holes and cutting them out and etching the boards and that sort of stuff. So anyway, that resistor I just put there, that's a 1K resistor. All that does is it's across ground and 0 volts and the base of Q18. Q18 is a voltage regulator which supplies the channel selector. So by doing that, it's reducing the voltage to the channel selector, which in turn reduces the voltage going to the POL section, which is what I need to make sure the EEPROM doesn't get blown up. Right, so I'll attach the TX wire to there. The other side's will come over here. So just there. So that's the TX wire that side. Right. Got the TX wire to the POL location, which is basically inverted of the normal TX. That's it's 0 volts on RX. So always leave a little bit of slack on here in case someone ever needs to take the front panel off for some reason. They have to remove the modification in the process, so I always leave a little bit extra wire. Okay, that's on to pin 8 of the POL location, which is the TX RX pin. Right, the next thing I've got to do is the lock detector disabling. So that's got to solder a bridge between pin 4 and pin 1. Let's get that all nice. Done to there as well. And always have a bit of component leg cut off from somewhere, which always comes in handy. Right, pin 4. Spin that around all nice. It's the advantage of through-hole stuff, you actually have bits of wire left over afterwards. And that's the lock detector one. I've also got to do a modification to the phase detector connections. So for the phase detector I've got to put a link between pin 6 and ground, and that is all I actually need to do. In this situation it just re-enables some of the existing phase detector circuitry with the filters system, and just trying to pick a piece of wire. Allows me to filter it properly, otherwise you get noise and stuff like that in the phase detector, but going between those two pins allows me to do that properly and gets good filtering. Took me a long time to figure that one out. Many hours of experimenting with different parts, part values, stuff on it, and in the end, just sticking a link between there and there does the job much easier. Okay, now the next part I've got to do is these two wires on the modification board. These are shielded cables. They're only shielded on one end because I found that's adequate. Rather than trying to put earth connections down the end, it's a bit of a pain. So they're all shielded at this end, and that does the job. So one of these is the reference signal, which is this wire here. That's the 10.24 megahertz connection. That's on the pin 2 of the POL location, and this other one here is the FN frequency. So that's the reference from the VCO, feedback from that. So that also needs to go on there, which is pin 9 of the POL location. So I'm just going to attach those now, and then we're getting close to actually doing some testing. So we'll get to that shortly. Okay, we're just about ready to start doing this. So now I just need to plug the ribbon cable into the board, like so. Now you notice you've got these two little earth prongs sticking out here. Those will actually get attached to the radio onto one of these coils, just to help secure these. They're actually a bit flimsier than I'd like. I normally use thicker ones from things like diodes, for example, power diodes. But this is what I've got to cut off, man, so I'll probably have to double some up and make it stronger once I've actually got it in there. So don't worry about those bending right now, I'll tidy it up after. So now I've got that connected up, all the wiring is done, so what I should be able to do now is actually power the radio up and tune the VCO frequency after I've just verified voltages are okay and that things aren't overheating, or in case something's not quite right, you never quite know. So let's plug the antenna in just as in case. Don't want to risk blowing the radio up, something doesn't quite go to plan. Plug the power in. Right. I'll plug in the microphone as well while I'm at it. Okay, so let's lift this up slightly so you can see a bit better, I think. Right. Now, what I need to do is just a little quick check on here, just to measure the VCO, or the phase detector voltage output. Currently there is 6.4 volts, which is probably okay. Just going to check a couple of these inputs on the PO, make sure I'm channel 40, so I've actually got signals coming back from the selector. Unfortunately this one's got a blown segment on display, but I'm not really too worried about replacing that just for one segment. It's not really worth it. So here we go, it's getting 4.5 volts. Yeah, 4.5 volts on those pins from the POL, which is perfect, so that's okay. The voltage regulator on the board, yeah, that feels fine, it's not getting hot. That all looks good. I can put the EEPROM in now and we'll go from there. Right, the last thing I have to do now is hook up the DC supply to the board, which I've already attached to the board just now. There's the wire. I've got to find out which pin on the switch it is. So that's showing 13.8 volts. That's showing nothing. That's where the radio turned off. So I'll show it, need to attach it to the red wire. Okay, so now I've confirmed it's all working. I've currently got that clipped onto the TP2 test point, which is the voltage that goes to the VCO to control that. As you can see, it's sitting at 3.3 volts right now. That's on channel 40 of the FCC band, and that's channel 1 of the FCC band. Flick it down to New Zealand, 1.1 channel 1, 1.8 channel 40. This hasn't been aligned yet, this still needs to be adjusted. If we go back to channel 40 on the FCC band with 3.3 volts, transmit, goes up to 4.8, 1, 2, 3. As you can hear, that's working. I've got my test radio set up on the same channel. So what I'm going to do is adjust the VCO to increase that voltage. It has to be done on transmit. So I want to find out what the limit is and make sure I set it below that to make sure it's definitely going to allow for temperature variations. So yeah, 7.3 volts is the limit. So 1, 2, 3, 4. See it? Hear that cutting out? So that's cut out there, and it's all a bit breaking up. See? So yeah. So I like to have a bit of a window of clearance. So let's go 6.5 volts transmit, and that should be good enough. Right, and receiver sitting on 4.8 volts, which is fine. Go to change the Siglent band, channel 1, which should be the lowest voltage it will do, because it's always a lower voltage on receive, they're not as on transmit on this radio. 1.8 volts. So channel 1 should be receiving definitely. Let's go to that channel on the radio. 1, 2. Yeah. Okay. That's definitely receiving. 1, 2. That's definitely transmitting. So those voltages are definitely adequate just for that. So that's the VCO setup. I've got to go through now and do the alignment on the various pots inside, well, coils inside. So as you can see, I'm tapped onto TP2 just there, which is resistor just there. It's not always marked. Some radios it doesn't actually have the marking there to say TP2. It's just a resistor leg there, and you just know to probe that and you can get it. So what I've got to do now is I've got to go through and adjust these coils. So this one here is adjusting the mixer signals here and a few other things. That's 10.24 adjustment there, which I'll also adjust. This one here has to be done transmit. That's again another mixer signal, which is done via test point. So this one here is tuned on this test point here. This one here is tuned on this test point here during transmit. These are the transmit mixers, sorry, filters. So those goes through those. 26 megahertz signal goes through those. Then through that one. The slug here for the I'll turn it around a little bit so you can see it. Hopefully. The slug there has already been taken out. If you look, you can see it's gone. So those are often taken out from the adjustment, because the sweet spot is actually with it not in there, strangely. Yeah, so I'll go through that alignment stuff, then we'll go from there. Once I get these cans all and the adjustments all done, then I can actually mount the board, because then the board will be in the way of them, you see. But once they're tuned, then that's it. They don't need to be touched again, so it's good. Okay, I'm afraid you have to excuse the angle. I tend to use my Tektronix scopes for this because it's got an output on the back. We can also see the VCO frequency. Unfortunately, my Siglent scope doesn't have an output, so I tend to use my Tektronix most of the time for this kind of thing. So what I've got to do is I'm currently on channel 40 FCC. I'm on test point TP3, and I'm adjusting L16. So the idea here is I need to increase this, adjust this to get a larger waveform on the scope. Okay, so it seems like it's a long way out from start off. So you have to check it on transmit and receive as well, because the frequency does change, so it drops down. So we'll see how we go. Yeah, it's all a bit. Yeah. Anyway, so we'll just do that. We'll just tweak it up here to make sure it's all nice and strong. So I've tuned it on channel 1 New Zealand, and that's already a lot better on channel 40 there. So I think the factory tuning is actually not very good on these for that tuning, or someone's been playing with it or something. I often find that one not set right. Now I'm going to go to TP4, which is L17's tuning in transmit. That's on FCC. That's channel 40 New Zealand. Channel 1 is in, so it's actually not looking too badly centered anyway. I might just give it a tweak on channel 1 New Zealand to see how it ends up on channel 40. So I'll peak it there, and channel 40 FCC is very low now, so I'm going to just balance it out. So channel 40 FCC, channel 1 New Zealand, yeah, it's close to right. I think I might just go slightly higher New Zealand. It's a bit of a compromise. It's just one of these things, you have to try and get that balance and try and get the best you can out of both. So, oops, my scope's a bit dirty there. Right. That's looking fairly even now. Okay, so that's that bit done. So that's those lines. Now what I want to do also is tune the 10.24 reference, because that is out of whack. I should have done that first really. So let's just get this on here, and let's see if I can. I don't think I'll better set my phone up for this actually, unfortunately. I don't think I'll be able to do it. Won't quite see it. Anyway, I shall probe on here and get the frequency probing at least. So there's the frequency there, and hold on a second. So unfortunately you can't see the frequency display from there. but you can see the waveform on the scope there. So I'm just going to tweak it. You have to take my word for it, I'm afraid, that I'm adjusting that to be on the right frequency. So it was sitting slightly low, it was just about 70 Hz low, which in itself is not too bad, but I like to get them closer than that. I like to try and get them as good as I can to start with, at least. It's getting closer, 20 Hz out now, slightly 20 Hz high, so I've gone a little bit too far with it. So I'm just going to keep on tweaking this until I get it just right. As boring as it is for video, especially when you can't see what I'm doing. It seems this VR's, well, this trimmaker pat's got a bit of a sweet spot there where it's not adjusting much. It's gone so far and stopped. It must be a little bit dirty. That does happen. Okay, now it's gone 25 low, so I might have to give it a bit of a spin around to get it working. Yeah, let's give it a twiddle. Right, let's try this again. Just about there. 10 Hz out. 5 Hz out. Is that close enough? 5 Hz? Nah, just slightly more. 2 Hz, 1 Hz out. I think that's close enough. 1 Hz is good enough. There you go. I'll grab the camera and I'll show you that. Flicking 2 Hz now, actually. So there you go. Right. And that's probing onto the reference input on my expansion board. Just there. I mean, it's actually coming from pin 2 on the POL location, which is just down there. And there'll be a test point there for it. I'll just go straight to the board. Let's see what the POL's saying. And that's it for now. I'm just going to go and have dinner, and I'll come back and do some after. So that's the board in. I've still got to secure the side yet. I'll just use hot melt glue for that. It's not ideal, but it works fine. It's sitting on a little ledge on that side, so I can't actually drop down. I've just tweaked that 10.24 megahertz crystal as well. So now it's at 3 Hz out, and New Zealand channels. So 3 Hz out, which is definitely acceptable. So now I just need to tune the receiver, and then I'm done. Now I'm going to try and check the sensitivity across the bands. So it's currently seeing about S1. So that's on channel 1 New Zealand. Just flip the channel to 40. Slightly lower. I'll do channel 1 on FCC band. If I do the right channel, it helps. So it's barely there now. And channel 40 on FCC is still there, but very weak. So I'm just going to balance it out a bit better. Just try and peak it slightly more on this one. And try and get a bit more sensitivity on this band, balance it slightly better. So let's go back there. Try channel 1 again on New Zealand. Yes, we can. So I'll probably just leave it there. Compromise. Let's try again. So that's channel 1 FCC. It's about the same as channel 1 New Zealand, so it's skewed slightly towards New Zealand, which is what I want. There you go. So, right. That'll do. Okay, there's the radio all finished, back together, all done. You may have noticed in this video, it's the first time I've actually been able to do some decent proper shots of what I'm working on. My lovely wife decided to buy me a little holder thing for my phone here, so I can actually stick on a tripod now and record what I'm doing, which should improve the look. So I thought I'd just mention that in case anyone's wondering why suddenly the video's changed a bit better. And anyway, there you go. All done. Have a good one.